Hello, math magicians. Today we're going to be talking about centers of data and weighted averages, and we're going to understand and also use summation notation. So by way of introduction, I want you to read through this real quick and then answer the following question. Why is this number misleading? And then I want you to calculate the average real quick. So go ahead and pause and do all that. So let's look at something called measures of center. Measures of center. So the mean, which has another name, most of you are familiar with it as called the average, is found by, of course, you sum the numbers and divide by the number of numbers. Sounds kind of funny, but it's one way to say it. Next, the median is found by doing what? So the quick way to find the median is simply by order the numbers, then find middle. In the case of two numbers there, you might need to find the average of the middles if there are more than one. These numbers are called measures of center. That's a more modern way of saying it. Measures of center, because it's faster. They used to be called the measures of central tendency. So make sure we spell correctly. Lastly, of course, the mode is the most frequent. You can actually have more than one mode. In the case where all things are equal, then there is no mode. You might say no mode. All right, so here we already talked about this, but we're going to use our calculators, or we did use our calculators. You're going to use the list button, the stat button, find edit, then you can start entering data into list 1 there. By the time we're done in this example, things will go all the way to L1 with the 15th right there. All right, after you press, again, the calc, we're going to press stat, then we're going to go over to the calc. One variable statistics is going to tell you things that you need, and just to refresh, this symbol right here simply means the mean. This one here means the sum of the terms. So when we add everything up, it's going to be 745. Now, my data here is wrong. It's different than what you had. And then this one right here just tells you the number of terms. And the next page says median. Med means median, of course. The med means median. But as you're practicing here, please note my error. Of course, that should be weight. There. So in this one, you can practice by entering each individual using this frequency table, putting 124 times into your chart, putting 135 3 times, and then choosing one variable, statistics, and it'll give you the data. So good. So we see that the number of team members this has is 14. And one place on the calculator it says that is when after one variable it says n equals 14. Of course, the other way to calculate that is just to add those up. Just find the sum of those. We'll explain that symbol in a moment. Next, find the mean height. So on my screen, it'll say 152.5 pounds. Remember, that says the X with the bar over it is the mean. Now find the median weight. And we get 140. Remember, that one says med equals, and it's usually on the second screen on the TI. All right, now looking at D, which number, the mean or the median, best describes the typical weight of a member of the team, and why did you choose that? So in this case, it does seem like the median would be a better display. If we were to look at things as a different representation, so notice this. In fact, it might be wise for you to actually copy this down, even though I didn't leave space for it. So I'll just do it up on the top. It's sort of a visual frequency chart that looks kind of like this. So if I just have a little number line here, kind of like a histogram, and I have 120 right there. I have 135 right there. I have 145 there. Notice this isn't to scale. I'm not mapping it out all the way accurate. You could, but for our sake, I'm just going to go fast. And then 285 up here. Now, you can do essentially a histogram, but just use X's or something to represent. So notice with the 120, I've got 1, 2, 3, and 4. And then with the 135, I have 1, 2, and 3. Same thing with the 145. With the 170, I have 2. Next, I have a 1 and a 1. And if I were considering what my average or my mean is, notice where the mean is, 152. 152 is somewhere here. But look at the vast difference. There are only 4 students here. And over here, I see that there are 10 students. So it's bottom heavy in terms of where all this data lies. And so it's probably, if we see that visually, we see that the 152 here is not an accurate one, but the 140 is pretty accurate because 140 is hanging out here. Now, I certainly wouldn't choose the mode 120 because that's bottom, way on the bottom. That's the lowest weight for these wrestlers. I'm going to give you a lot more background than you need right now, but I think it's important, or at least fun. And we're going to look at something called the summation notation. Also called, might as well throw this up there because we see it a lot, also called sigma notation. Sigma notation. So some background on just math history here. So back in the olden days, a guy named Nicolai Erasme was adding the same number 2, and in Latin it says and, 2 and 2 and 2, so he says 2 et, 2 et, 2 et, 2 et. And he realized, well, you know what, if I'm going to use the word et a lot, so et meaning and in Latin, if I just got rid of the e and just deleted the e, great, I'm going to save some time, save some energy. And so effectively he did that, dropped it, and he said 2 et, 2 et, 2, and now we read it as 2 plus 2. Great. Well, along came some other geniuses, and they invented the same, even more when writing the same number multiple times. So in this case, 2 was added 4 times, so then they just changed it to 4 times 4 using a different symbol. Okay, now we see when we repeat stuff a lot, then math helps describe that very well. So 300 years later, along comes Leonard Euler. It's pronounced Euler, one who oils, but that's just an odd way of pronouncing that. And he was adding consecutive numbers. Consecutive numbers are numbers in order. In order. Anything can be consecutive. For example, people standing in a row, you guys right here, are consecutive. I can say consecutive letters, A, B, C, D, M, N, O, P. Those are consecutive, just in the order that you've determined. And then he was also looking at groups of numbers. So in the last column of this table, I don't have a table below. It's above, on the next page. All right, so he said to himself, I'm summing a bunch of consecutive numbers, and I don't want to write 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Of course, you can keep going. What if I was going to add all the way to 100? That's redundant. It's so much to write. Okay? So this is what he did. He took the capital letter for S. It's our S. That's the sigma right there. So it looks like an E, but it's actually an S. And he wrote this right here. So he said, and this is what it means add a bunch of numbers starting at 1, ending at 10. Okay? So this means the start, where am I going to start? Am I going to start at the number 1, or am I going to start at the first term? What? The top tells you where you're going to end. I'm going to end at the 10th term, or I'm going to end at the 10th number, whatever. And then, of course, this is some sort of a function or some sort of inequality or something. So that gives you the instructions. So this is how we interpret this one. Beginning at 1, keep adding until we get to 10. And x represents each number. X is a 1, then x is a 2, then x is a 3. So we just substitute in the subsequent numbers. Okay. Now, let's just practice and look at A. I'm just going to show you how to interpret this. Again, it looks way fancy. It's fairly quick once you get a hold of it. So this says I'm going to start by substituting a 1 in. Okay? So my first term is 1 minus 1. So my first term is a 0. Next, I'm going to keep substituting in the next number. Now I substitute in a 2. 2 minus 1 is 1. Next, I'm going to substitute in a 3, and I get 3 minus 1. Then I substitute, lastly, I substitute in a 4, and 4 minus 1 is 3. So, what is this? How do I interpret this whole thing? This whole thing says I'm just going to add 0 plus 1 plus 2 plus 3. And that's it. So this does have an answer. I can evaluate this. So it simplifies to 6. So this whole thing equals 6. The work is kind of like evaluating each function. You just plug in this right here, evaluate what you get. Plug in the next one, evaluate, and then stop. The 4th term goes there. All right, for our purposes, we'll finish this up real quick, just to show you the work that's happening. When I substitute in a 3 minus a 1, I get a 2. Then I get a 1. Then I get a 0, ... all the way up till I get to negative 5. And the sum of this is negative 12. This one over here is only adding a few numbers together. So 2.5 plus 4.5 plus 6.5 plus 8.5. And do you remember what I got on that? Was that 60? 22? Okay.